So this is your solution to that problem. Multiple choices is a big deal. A couple things to note about multiple choices. If you have multiple choices, you must make sure that you have your output tunnels hooked up in all cases. For instance, if I forget to hook up this in true, I'm just going to break this wire so there's no output. Now, if I'm looking at the false case, I can't tell that that's not hooked up necessarily. It looks like that tunnel's hooked up in this case, but notice that that tunnel is not filled in. If a tunnel is not filled in, that means one of its inputs is missing. So if you see one of these things that isn't filled in, you go, oh, I didn't hook it up here. Or the other thing that's true is that I can't run the program. Because what is LabVIEW going to put on that wire if those conditions happen? It doesn't know because the tunnel isn't hooked up. What would it put on this wire? It doesn't know to put that on it because you didn't tell it. So it says your tunnel is missing an assignment to the tunnel. You double click on that, it shows you which tunnel is missing. You hook this back up and you're all set. Another important thing to know is that you have to have a question that is answered by the case structure. Here, the outside case structure is answering the question, is my height above 7? The inside case structure is answering the question, is my height below 4? And so both of those questions have to be hooked up. The outside case structure doesn't need this second question because it only answers one of the two questions. The inside case structure answers the other one but doesn't answer the first. So each case structure answers a different question, and those questions are asked by certain functions or certain conditions being met. Does that make some sense?
And a useful tip.
A useful tip from Mr. Jednak. If I make the case structure taller, yes?
Right-click on it. Say visible items.
Visible items.
Up at the top.
Yep, I got it.
Label.
Label.
Subdiagram label.
Sorry, right-click, visible items, subdiagram label.
And then you can put comments in there.
This is the greater than 7 case structure. Or something like that.
Yeah.
And then, oh, okay, that's good to know. So there you go. You can comment the cases. All right. So this is actually a pretty useful algorithm all of a sudden. I know it was a little painful at the end there because we had to get this understanding about nested cases, but we've just made something that we can use. If I'm looking with my camera and I figure out that the center of the goal is somewhere, I can now figure out if that's too high and I've got to move my shooter upward, or if it's too low and too high and I got to move my shooter downward, too low and I got to move my shooter upward, or if I'm ready to shoot. This is pretty useful. So if I wanted to use this code in another piece of code, what I have to do is turn it into a sub-VI. So VIs are functions. So basically what we're making is a sub-function, right? The easiest way to do that is to take everything that you want to have happen in the sub-VI, draw a selection box around it. So let me do that right now. Draw a selection box around it, like so. Notice I didn't include the while loop. Why didn't I include the while loop? Well, if I want the function to happen and be controlled by another program, I basically only want it to happen once. I want it to be called by the other program and happen once. Usually you don't have loops inside of sub-VIs that are going to be part of your execution flow. I'll show you where sub-VIs can have loops in them when we get into the robot. But in general, the sub-VIs that you make are not going to have loops in them. What happens when you do put a loop inside of a sub-VI is the sub-VI starts running, it keeps looping forever because you can't tell it to stop. Okay? So, I pick everything that's inside the loop, but not the loop itself, and I go to Edit, Create Sub VI. See that? Edit, Create Sub VI. Watch what happens. Voila! Boing! It's made a sub VI. What's a sub VI? Well, a sub VI is a graphic. It's a square. It's a function, because we made a function. How do I get into this sub VI? How do I find the code that's in there? We do some reorganizing while you're thinking about that. How do I get back to the code that's in there? What's the thing that I do if I don't know what to do? I right-click on what? On it. I right-click and I can open the front panel of this sub VI. So now we've opened up a new sub panel, a new front panel. This is untitled 2. This is untitled 1. I could call this main and this sub VI. So I've opened up a new front panel, Control E, and there's my code. So that code is now inside of another function, or inside of a picture. Why is that useful? Well, let's take a look. Let's say I open up another program. And actually I'm gonna do this way. I'm going to open up my sub VI and I'm going to save it. File, Save As. I'm going to save this sub VI into my desktop and into my FRC, and we'll put this right in the videos folder, and we're going to call this FRC Week 2 Sub VI. Now you'd probably want to give this a much more descriptive name, like it would be shooter, actually let me do that. FRC Robot Shooting Sub VI. What day is it? 1/11/2013. What time is it? 4 p.m. Oh my goodness, it's 2014. Ugh. When you get old. I'm surprised I didn't put 1994. Okay. There we go. So it's now saved. I'm going to close all this up. I'm going to save that as well. We'll call this my main VI. Main FRC training main. Okay. So now I get back to the splash screen. I'm going to open up a blank VI. It'll take just a second to wake back up. When I open the blank VI, I'll have a new front panel and block diagram. On the block diagram now I can right-click and select a VI. And notice one of the VIs I can select is the robot shooting sub VI. Double-click, and there it is. What's its input? Height. What's its output? Too high, measured height, and instructions. Hey, that's pretty cool. And by the way, I know if this works and I put it into my robot code, it's going to work there. So if I've tested this sub VI, I know it works. If I put it into another working piece of code and hook it up appropriately, that code's going to work. This is called modular code making. So you might want to have different people on your robot making different sub VIs that do different things. You got to know the inputs and outputs, and then you hook them up. Yes?
How do you get the front panel of the sub VI?
So the question is, how do you get this back to that sub panel? So sub VI's front panel. How did we do it before? You right-click on the sub VI, open front panel, and there it is. And notice, in this one we've got a connector block hooked up. 1, 1, 2, 3, right? Great. So I want you all to make a sub VI out of the interior part of your while loop, and I want you to save it with a name that's appropriate. I want you to save it with a name that's appropriate. I want you to close everything out, open up a new VI, and use on the block diagram, the select a VI option to select that VI and bring it into your code. So there's 4 steps. Can you keep those steps in your head? You're going to close everything. You're going to make a sub VI By selecting everything inside the loop and going Edit, Create Sub-VI. Edit, Create Sub-VI. You're going to save that sub-VI with a name you can remember. You're going to close everything up. You're going to drop that sub-VI into a new VI that you reopen or remake by using the selective VI function. Okay? Great. Have at it. Oh, there was a question, yes.
So if I've got a front panel on a sub-VI, and I want to make that part of the higher level sub-panel, how do I bring them out to the...
So the question is, if I have a front panel of a sub-VI and I want to bring that information up to the main VI's front panel, then you have to have outputs from that sub-VI with that information in it, and make a new set of places on the front panel and hook them in appropriately. That's a great question.